Fuck's sake. Oh, what the fuck? Hey, Aim, come here. I got ult for you. After you kill him. Come mid, boys. Go mid, don't TP, just keep pushing. Coming mid. What? Alright.
But this seems like a pretty decent talent. He seems about the same. Necrophos strength gain from 2.6 to 2.3, so nerfed. Death pulse damage increased from 100 through 250 to 100 through 280. Heal increased from 60 through 120 to 60 through 135. Ghost Shroud self-restoration amplification from 75% to 45% through 75%. And the level 10 talent, 25 damage, replaced with 100 Reaper Scythe cast range. This actually seems like he kind of got nerfed, dude. He seems like he got nerfed, and he's not that good already. Night Stalker, base damage increased by 2. Dark Ascension cooldown has been increased from 140 through 120 to 150 through 130. Talents, level 10 talent, 6 armor replaced with plus 10... Wait. Really? Wait. Is this 10 seconds? Am I crazy? 6 armor replaced with 10 seconds Dark Ascension duration. I mean, that's fucking crazy for a level 10 talent. What? No way. This has got to be wrong. I don't know. This seems nuts. Level 15 talent, 12 strength replaced with 50 Dark Ascension damage. Wow, dude. 20 talent, 35 damage with 25 strength. Okay, dude. If this is real, Night Stalker's busted. That's nuts. That's nuts. Nyx Assassin, base strength reduced from 18 to 17, base agility from 19 to 18, base health regen from 2.5 to 2.0. These are pretty insignificant. Burrow HP and mana regeneration from 1.5 to 1.1%. 1%. So, seems fine. Seems fine. Nyx still seems fine. Ogre Magi, strength gain from 3.5 to 3.3, so nerfed. Shard, Fire Shield no longer procs on creep attacks. Fire Shield fixed, recasting Fire Shield on an ally, not replenishing its charges. Fire Blast damage from 60 through 240 to 70 through 250. Unrefined Fire Blast mana cost increased from 30% of max mana, current mana to 35% of current mana. Ignite mana cost reduced significantly in the early game, 110 to 80 through 110. And then the talents, 20 talent, 30 attack speed, Bloodlust to 25 attack speed on Bloodlust. So, yeah, really the big thing here to me seems like Ignite in the lane is really good for just spamming that shit. Like, Ogre seems good in lane. And then all of the other stuff seems kind of insignificant. But the laning seems really good. Omni Knight, strength reduced from 24 plus 3.4 to 23 plus 3.1. Agility gain increased from 1.8 to 2.0. Heavenly Grace, bonus strength increased from 8 through 32 to 8 through 38. Guardian Angel, cooldown reduced from 160 through 140 to 160 through 120. Hammer of Purity no longer heals Omni Knight on attack, no longer can be cast on creeps, now puts a debuff on the enemy which reduces the enemy's outgoing damage by 60% by 4 seconds. Mana cost increased from 20 to 40, cooldown increased from 4 to 10. I'm going to say this is not that good. I think Omni's quite bad. Maybe I'll eat my words, but this was like a carry thing people were doing, and increasing the cooldown on this and removing it from hitting creeps removes the carry ability to this, and that sucks. Oracle, armor increased by 1. Cooldown increased from 2.25 seconds to 2.5 on Purifying Flames, so nerfed. And the False Promise duration has been reduced from 8 through 10 to 7 through 10. So Oracle's nerfed. Okay, slightly. OD, Arcane Orb now affects Roshan. That's big. Astral Imprisonment. Fixed debuff, not displaying correctly. Okay, well, that's nice. Grants an additional 5% mana capacity steal to Astral Imprisonment. Also now allows allies to move at 40% move speed during Astral Imprisonment. Okay, so I think this is the Aghanim Scepter that does this, and they just don't have it written here, I would assume. Which seems good. This actually seems really good. 40% move speed. I mean, they can, like, get out of fights. That seems nuts. That seems pretty nuts. I think offline OD is probably legit. Pangolier, Shield Crash, now slows enemies for 25 through 40% for 3 seconds. Damage reduction per hero has been increased 12 through 18 to 15 through 18. Damage reduction rescaled. The duration from 10 to 5 through 11. Cooldown reduced from 18 through 12 to 16 through 10. Okay, wow, that's nuts. Giving Pango just a guaranteed slow. Oh, well, okay. Lucky Shot no longer slows enemies, I see. Lucky Shot no longer slows enemies, but the armor reduction has been increased from 3 through 6 to 4 through 7. I mean, you're guaranteeing that, like, you can set up for your own ult by just shield crashing on them. That seems really fucking good. Pango seems nuts. Phantom Assassin, Stifling Dagger, slow duration from 1.75 through 4 seconds to 2.2 through 4 seconds, and the 175 health talent level 10 has been replaced with 1 second on Phantom Strike duration. So, yep, seems fine. Bit of a buff, nothing big. Phantom Lancer, Juxtapose, Aghanim Scepter cooldown reduced from 60 to 40, and the Aghanim Scepter now increases the max illusion count by 2. That still sucks. Phoenix, Icarus Dive, dash length from 1400 to 1100 through 1400. So nerfed. Sunray, max health as heal per second reduced by a slight percentage in the early game, and then by 0.5% in the late game. And the Fire Spirit's radius has been increased. So Phoenix, slight nerfs in my opinion. Puck, base damage increased by 1. Cooldown on Phase Shift increased by 0.5 seconds. Dream Coil no longer has an initial stun. It still cancels TP since it leashes the target, so it doesn't stun. And the 10 talent, 25 attack damage has been replaced with 300 orb distance. So Puck is less of a scaling core now, but still seems fine. Okay, Pudge. Oh, this is small. This is small. Okay. Pudge, Meat Hook, mana cost rescaled from 125 through 140 to 135. Okay. So better later. Now instantly kills. Oh! Oh my god! It's like Christmas morning! It kills creeps! Oh my god! Pudge can fucking farm! Yes! Yes! Oh! I'm so fucking happy. I am so fucking happy. You have no idea. This is real happiness. Oh my god, I didn't know I could be this happy anymore. Okay, I'm spamming the shit out of Pudge, bro. Pudge is Mirana, man. You can jungle Pudge. You can jungle and punch. You're hooking hard camps. Bro, you can contest camps. Fuck, that's awesome. And now you counter Beastmaster? Now you counter Enchantress? Oh my god. Alright. Keep it cool, Jenkins. Still got quite a bit left to go. Oh, fuck me. That's good, though. That's really good. Dismember Shard cast range on allies reduced from 400 to 300, which doesn't matter because now you can actually farm because you insta-kill creeps. Oh, I love Ice Frog. Ice Frog, I literally am in love with you. I will be breaking up with my girlfriend tonight. And send me your number, please. I'm in love with you. Pugna. Nether Ward no longer has a mana-reducing aura. Now additionally heals 2 hits whenever it triggers. Heals... Oh, okay. That's pretty... Wow, that's pretty cool. That's really cool. The mana-reducing aura was pretty important, though. Like, that was annoying. Talents, 15 talent from 0.8 seconds. Nether Blast cooldown to -1 second. So Pugna seems just about the same. Queen of Pain, base damage increased by 3. Shadow Strike now heals Queen of Pain for 10 through 40 health on every tick. Heals 50% on creeps. Tick damage reduced from 30 through 90 to 20 through 80. Wow, that seems really good for laning. Maybe side lane Queen of Pain is back. Talents, level 15 talent, 10% cooldown reduction, replaced with 2 Shadow Strike damage instances, same duration, ticks happen more often. Ooh, so it does more damage. Level 20 talent, 30% spell lifesteal, replaced with 120 Scream of Pain damage. This seems like it could be really good in side lanes. Like, base damage increased by 3 too. That's pretty nuts. Razor, Eye of the Storm, now applies its armor reduction before applying its damage. This is, okay, great. Very slight nerf, or sorry, buff. Talents, level 10 talent, 175 health, replaced by 30 plasma field damage. Okay. 20 talent, 8 armor, replaced with 6 seconds static link drain duration. Oh, drain duration. Wow. So you're getting more damage then. So late game Razor's better, much better, but everything else seems the same. Riki, Blink Strike damage increased from 25 through 100 to 40 through 100. Tricks of the Trade, damage per attack from 50% to 40%. So, man, core SD might actually be pretty good with that, but, you know, that's asking a lot. Shadow Fiend, Necromastery, reworked Shard. Necromastery is now an attack modifier that consumes 1 soul, granting your next attack 170% crit with a 3-second cooldown. Additionally, enemies killed grant an extra soul. An extra soul, like, permanently? Or just an extra soul... Grant an extra... Oh, I guess because... This would just give you the ability to spam it. 170% crit. That doesn't seem that crazy. Requiem of Souls. Slow. Rescale from 25% to 20 through 30%. Level 10 talent. 20 attack speed to 25. Level 10 talent increased the 6% spell amplification to 8%. The 15 talent, 25 move speed, replaced with 80 Shadow Raise damage. That's pretty good. Level 20 talent, 120 Shadow Raise damage with 0.3 seconds Requiem Fear. Slow per line, so it's got 1 extra second on it, max. 25 talent, 30% cooldown reduction, replaced with 40 seconds off Requiem of Souls, which might make it a really low cooldown with the Arcane Blink, but it already was a really low cooldown with the Arcane Blink, so I don't know. SF seems about the same. Maybe I'm an ape, because I don't play that much SF, though. Mass Serpent Ward cooldown rescale from 120 to 130 through 110. Mana cost reduced from 200 through 600 to 200 through 550, so still very expensive. Talents, level 10 talent, 175 health, replaced with -3 seconds on the Hex cooldown. Level 15 talent, 5 seconds Hex cooldown, replaced with 1 second Shackle duration. That's good. 15 talent, 75 Serpent Ward attack range to 100. 20 talent, 2 seconds on Shackles duration with Hex breaks. Wow, another break. That is good. That makes Shadow Shaman's late game. I mean, that's the point you want breaks, right? Like, breaking a Spectre or something at that point seems very busted, or Bristleback. So this gives him a lot of utility in the late game. But still about the same in the early game. Silencer, who needs a lot of buffs. Let's see. Strength gain reduced from 2.7 to 2.4. Arcane Curse now deals double damage when slow when the target is silenced. Penalty duration reduced from 5 seconds to 3 seconds. I don't feel like that's that. Maybe if you Arcane Curse somebody, you're like slamming them during the global, but it doesn't seem that sick. 10 talent, 6 armor, replaced with 15 Arcane Curse damage. Okay. That's a lot of damage. 15 talent, 30 arcane curse damage with 100 attack range. 15 talent, 2 permanent intelligence per kill with 10% arcane curse slow. 20 talent, 100 attack range, and I don't think this is all good. 20 talent, 100 attack range replaced with 400 health. 20 talent, 20% arcane curse slow replaced with 1.5x last word int multiplier. 25 talent, 30% cooldown reduction replaced with last word mutes items. That's a 25 talent. It's not really that crazy. Then again, you do have the Aghanim. You do have the Aghanim Scepter, which makes the arcane the last word go on AoE. So, I feel like this is still a pretty bad hero, just because like they're trying to make people play around this arcane curse slow, but it's still a slow, and it's still this long cooldown. It's really gimmicky. And then they removed the 2 permanent int per kill, which I think was one of the biggest reasons the hero might be viable. So I think Silencer's still bad, but maybe I'm wrong. Scarith Mage, base damage increased from 60 through 135 to 75 through 135, so buffing that again. Concussive shot movement speed slow, rescaled from 30% through 45% to 40%. Mystic Flare duration reduced from 2.4 seconds to 2.2. Now the question is, does it still do the same amount of damage? And I kind of feel like it does, because I don't see why they would nerf this hero. So that seems like this hero could be quite good. Slardar, Guardian Sprint cooldown increased from 17 to 32 through 17. Bonus move speed increased from 16 through 40 to 25 through 40. Okay, side grades, cool. Slithering Crush damage rescaled from 80 through 60 to 70 through 280. Side grades as well. Talents, level 10 talent, 20 attack damage replaced with 3 seconds off Guardian Sprint. Level 10 talent, 7 HP regen replaced with 10% Slithering Crush attack, move, and slow. 20 talent, 25% lifesteal replaced with 100 Slithering Crush damage. Slardar still seems kind of sus. Slark, self damage reduced from 50% to 30% on Dark Pact. That's pretty good. Shadow Dance, cool, but then again, you heal a lot. Shadow Dance, cooldown reduced from 80 through 50 to 75 through 45. That's probably a bigger deal. Level 10 talent, 9 strength replaced with 1 seconds off Dark Pact. Level 15 talent, 18% lifesteal replaced with 50 Shadow Dance attack speed. 15 talent, 20 attack speed replaced with 80 Dark Pact damage. Level 20 talent, 120 Dark Pact damage replaced with 1 Agi per Essence Shift stack. Wow. Now the question is, does that count the permanent stacks, and does that count the actual stacks that you gain from hitting people? And if it does both, this seems like it's quite good in the late game. This gives Slark actual late game viability, which the problem was, like, he would get a lot of items, and then he would still need to hit people a lot to do damage. So this seems pretty decent on Slark. Snapfire, strength gain from 3.3 to 3.5. Fire Snap Cookie, mana cost reduced from 110 to 100. Mortimer Kisses, burn damage increased from 50 through 100 to 60 through 100. Cooldown reduced, rescaled from 110 to 120 through 100. Strength gain buff is probably the biggest thing here. These are slight buffs. 10 talent, 20 move speed replaced with 1 second scatterblast slow duration. Okay, that's cool. Very nice. Sniper, shrapnel. All right, here we go. I'm excited about this one. Sniper, shrapnel damage, buffed by 5, which it already does a lot, so this is great. Take aim no longer grants true strike. It sucked. That's okay, guys. Active self move speed slow increased from 25% to 45% through 30%. Active headshot chance increased from 70% to 100%. So you're going to headshot every time. Cooldown reduced from 35 through 20 to 20 through 14. Mana cost reduced from 50 to 25. Duration from 4 to 3. So that still seems about the same. I mean, yeah, Core Sniper was bad, and it probably still is bad. Concussive Grenade, knockback increased from 450 to 475. Self knockback from 425 to 475. All right, Sniper 4 was decent. He's probably still decent. Wait. 15% cooldown reduction replaced with 1 second take aim duration. Okay, Sniper fucking sucks. This cooldown reduction talent was like half the reason he was picked. He sucks. Spectre, reworked Shard. Causes dispersion to fire a spectral dagger every 300 damage absorbed in the direction of the last source of damage. Can fire a maximum of 1 dagger every 7 seconds and only triggers off player-based damage within 700 range. This seems good. That seems really good, because she's always going to have that move speed and be slowing people. That's really annoying. Spectral Dagger is dispellable. Thank God. Shadow Step. Fix being able to target creep hero units. Okay, talents, level 10 talent, 5 HP regen, replaced with negative 5 seconds off Spectral Dagger cooldown. At level 10, that's nuts. 15, 8 seconds off Spectral Dagger cooldown, replaced with 100 Spectral Dagger damage. So this seems, to me, this debuff being dispellable is a big nerf, and everything else is just side grades. Spirit Breaker, this is the T-Gov hero. Let's see if he got some buffs and if he'll be happy. Strength reduced from 29 plus 3.1 to 27 plus 3.0. They seem to be reducing the strength on all these heroes. Charge of Darkness, mana cost increased from 70 through 100 to 100. Scepter no longer grants 175 bonus move speed. Scepter now pierces spell immunity and reduces cast point to 0.1. So, I mean, it already pierced spell immunity if you pre-charge them or you charged through them is the thing. So that's one issue. But that could be really good. Greater Bash now deals 1.5x damage to creeps. Oh, so he can farm a little bit. Core Breaker, even 4 Breaker, 5 Breaker, you can farm creeps. 15 talent, 10 HP regen with 4 seconds off Bulldoze. 20 talent, 5.5 seconds off Bulldoze. Has been replaced with 200 move speed during Charge of Darkness. All right, okay, so they added that to a talent. 20 talent, 12% greater bash damage, replaced with 10% greater bash chance. I see. 25 talent, 20% greater bash chance. Okay, so they flipped those. Cool. Spirit Breaker seems the same. Storm Spirit, static remnant damage increased from 120 through 285 to 120 through 300. Ball Lightning, starting mana cost reduced to from 30 plus 8% to 25 plus 7.5% more. Fountain Zips, boys. They're coming.
What the fuck? Yeah. Who's that? Sono battery back. Hey, come here, I'll hook you. Yes. Gilmore. Gilmore's. I didn't want to wake you up.
Just defense spec. Good ult. Good ult. That Gale Force. Gale Force.
Hello, everyone. Get on that wait list. We're going to go and scale up as quickly as we can and try to get this out to everyone. So the second way that you can get access to Codex is we're going to be hosting a new kind of programming competition. This will be held on Thursday at 10 a.m. Pacific. Everyone's going to get access to Codex as their teammate. It will also be a competitor on the leaderboard. So it'll be really interesting to see what it's like to work with Codex. Everyone's going to be able to play with it and be able to really experience the kinds of things we're showing you today. So please show up. It's going to be a lot of fun and I think a very unique event. So all right, let's get started with the demos.
Cool. Thank you, friends. Have fun.
All right. See you later, Wojciech. All right. Hello, Greg.
Hey, Ilya.
So you have a coding demo,
We do. So there's only one way to start a coding demo.
and that is Hello World.
All right, of course.
So what you see here is that Greg is typing "Say Hello World" into the text box. Now he'll press the green play button. The model will produce the code, and then we'll see its output below.
And so, exactly right. So what you're seeing here is a simple interface we built on top of the Codex API. So everything you're going to see today is just using the same API everyone's going to get access to. So you could build the exact same thing. So this very simple interface, all that we do is we format the instruction to the model, and we happen to format it a little bit like a Python doc string, so that it looks a little bit like a comment. The model generates code, which we then just execute, and the output is displayed here. So as a user of this kind of system, you just kind of ask the computer to do something, and it actually does it.
Well, it looks like he did a good job with Hello World, but let's make it a little bit more complicated. Let's say Hello World with empathy.
Say hello world with empathy. Interesting.
Yes.
All right.
It's just a slightly ambiguous instruction.
Do you know what you would say to this?
I mean, I can think of multiple things. I want to know what the model will
All
say.
right, let's see what happens. I think that's actually a very reasonable choice. And you can ask the model, you can modify your instructions to the model as well. So the kind of thing that you can do is you can also ask it for information that is kind of stored in a session. So now I'm going to say, instead of saying hello world with empathy, I'm going to say it with empathy. And again, the model is kind of free to make a choice of what it wants to do with that. In this case, it decided to do the same thing, which I think is a reasonable choice. It formatted the code a little bit differently, but fundamentally, if you notice, it now has to kind of back reference to the previous part of the conversation. And under the hood, this is just a single request to the Codex API that we're formatting just like you would a GPT-3 request. So it's almost like a chat session of human model, and so forth.
So it looks like the model did a satisfactory job with saying hello world with empathy, but could it say it 5 times?
Okay. Now that's an awful lot of empathy.
I think it did not a bad job, but it's not quite exactly what I wanted. I wanted to be hello world with empathy, with each one of those things appearing on a new line.
Now, if you want to look at the code, you can. That's the great thing about a model like this, is it's very interpretable. And so you can actually look and see, hey, this just did print where it multiplied by 5. So you couldn't say, instead say, now instead, do it with a for loop.
Hello world with empathy 5 times.
Okay. Now that's an awful lot of empathy.
I think it did not a bad job, but it's not quite exactly what I wanted. I wanted to be hello world with empathy, with each one of those things appearing on a new line.
Now, if you want to look at the code, you can. That's the great thing about a model like this, is it's very interpretable. And so you can actually look and see, hey, this just did print where it multiplied by 5. So you couldn't say, instead say, now instead, do it with a for loop. Which again starts to be a lot of back referencing. But there we go. Is that what you wanted?
It also did what I wanted as a byproduct, in addition to doing it with the for loop. So
Very
I'd say
nice.
it's not a bad start for a hello world demo.
Yes.
But I think we can go further.
All right.
We should say exponentially more hello worlds by
do you want to do
making
that?
it. We should make a web page.
We've got to make a web page if we really want to broadcast our message of hello world to the world. So first of all, make a web page that says, let's say our message, and save it to a file.
Ooh,
Yeah,
curious
a
what it
little
will
bit
do.
tricky, taking a little bit of a risk here.
It worked.
There we go. So if you notice, if you can see the code, it's actually writing Python that then emits some HTML. And that's, again, one of the powers of this model, is it's a single model that's proficient in over a dozen programming languages. And that means it can kind of just seamlessly figure out, okay, I'm supposed to be doing HTML here, or if you want to translate from one language to another, it's quite good at that. And I think this shows you why you really want all of that capability in a single model.
Okay, so is that all we need for a web page?
Well, we should probably let people see the web page.
Seems like a good idea.
All right, so let's start a Python web server to serve that page. Let's give that a try.
It looks like pretty complicated specialized code.
Yes, so let's actually take a look. So we have web server running on port 8000. So we'll take a look. Oops, oh, it was 8000, excuse me. And there we go, hello world with empathy.
Oh, I would say it's a success.
I think it's a success, yes. So this is the first time we've ever generated this particular message, so we actually didn't know what it was going to say. So you know that this particular web page was in fact generated just now on the fly for all you viewers out there.
I think that was nice to say hello world with a web page, but we should go further even still.
I think we should. And so, first of all, I do want to point out that this particular example of writing a Python web server is something I've done a dozen, 2 dozen times, and I still never remember how to do it. Because between Python 2 and Python 3, the exact structure of the modules changed, that you have to create this handler object, you pass it to a TCP server, that you pass the address here and a port, and oh yeah, your address can be an empty string if you want, and then you do serve forever, and it's complicated. And this kind of stuff is not the fun part of programming, right? The fun part of programming, I'd say programming is kind of 2 things. One is understand the problem, and that includes talking to your users, that includes thinking super hard about it and decomposing it into smaller pieces. This is the really cognitive aspects of building something. And then there's a second piece, which is map a small piece of functionality to code, right? Whether it's an existing library, an existing function, whether it's in your own code base or out there in the world. And that second part is where this model really shines. I think it's better than I am at it, because it really has seen the whole universe of how people use code. You should think of it as a model that's, GPT was trained on all the text out there. This model's been trained on all the text and all the public code. So it really, I think, accelerates me as a programmer and takes away the boring stuff so I can focus on the fun ones.
Okay, so that is a working web page that you've got. But wouldn't it be nice if you could send lots of emails with Hello World to everyone who is listening to us on the live stream?
Yes. So here's a moment for everyone to participate. So if you would like to receive an email as part of this demo from Codex, I think that we should be posting a link to sign up into the chat now. It should also be displayed on the screen, so please go ahead and sign up, and we'll give you a moment to do that.
And while we are waiting for you to sign up, I want to point out how insane it is that what we are showing to you works at all. It is fundamentally impossible to build such a system, except by training a large neural network to do really good code autocomplete. That's all we did. It is really simple conceptually, though perhaps not in practice, to just set up a large neural network, which is a large digital brain, which has a mathematically sound learning procedure. And that part can be understood, and it is relatively simple. And then you make it work. You make the neural network big, you train it on code autocomplete. And by being good enough at code autocomplete, we get the capabilities that you see here. It actually reads all the letters, all the words that we are giving it. It chews and digests them inside of its neural activations, inside of its neurons. And then it emits the code that we see. And because the autocomplete is so accurate, the code actually runs, and it runs correctly.
So now, let's show you how to hook Codex up to sending email. So we're going to be using the MailChimp API in order to do this. And Codex again has seen all the public code out there, but I want it to use my MailChimp account, and maybe I have a particular way that I want to call the API. So it's very easy to give Codex new capabilities, almost the same way that you explain to a programmer how to use a new method. You can do the same thing for Codex. And so I want to show you the only magic that's going on here is that we have this plugin where on the left is instructions for humans, and we can take a look at the actual code that is supposed to be installed on our system. It's just a very simple wrapper around the MailChimp API where I plugged in the API key already. And now we can simply take this documentation written in very readable form and paste it to the model.
So literally just those 3 lines of text is enough for the model to understand how to use the API.
Exactly. But before we send the message, what actual message should we send to people?
I mean, the should
Exactly.
is enough for the
To the model.
So literally just those 3 lines of text is enough for the model to understand how to use the API.
Exactly. But before we send the message, what actual message should we send to people?
I mean, this is obviously a hello world, as well as something truly useful, like the price of Bitcoin.
That sounds extremely useful. So we'll ask the model to look up the current Bitcoin price.
Let's see if it works.
All right, so it seems to have done something. And by the way, this particular API, I guess, is used enough out there in public code that the model felt it was worth its while to memorize exactly how it works. And now let's actually send the email blast. Now send everyone an email telling them A, hello world, and B, the current Bitcoin price. So we'll leave it a little bit up to the model to decide exactly how it wants to format that email.
Yeah, I'm curious what message it will choose.
Let's see what happens. All right.
Oh, looks like a very sensible message.
Indeed. So now it's calling the MailChimp API. So let's give it a moment. Spinner is still spinning.
Yeah. So it will probably, oh,
There we go.
that's a lot of emails.
Yeah, so we're sending 1,472 emails. It may take a little bit of time for these to deliver. Again, at this point, Codex has done its job. At this point, we've made the call to MailChimp. MailChimp is queuing these emails up on its servers as we speak. But as you receive the emails, please post in Twitch chat so everyone knows that they were received.
So I feel like it was a pretty satisfactory Hello World demo.
I think this is the world's most advanced Hello World demo.
And while 1,472 lucky recipients are waiting for the email, it's time for us to move to our next stage.
I think so.
Let us build a game.
All right, so we've shown building, sort of very simple functionality, right? So that it's kind of single shot, it required a little bit of back referencing, but mostly it's you ask for a particular thing you want done right away, and maybe it involves doing some complicated import of a particular API and use it in a specific way. But what we want to show now is building up a more complex program, actually, sort of building something that spans many lines of code.
That's right. And the game I have in mind is one where a person will be trying to dodge a boulder.
All right, well, let's give that a try. So first of all, I'm going to look up a silhouette of a person. I figure we should probably not use a real image of a person for this because they're going to get squashed by a boulder.
That is a very wise choice. And what you see here is something very similar to the previous demo, where Greg is typing the instruction to the text box, then he presses play. The model does its neural magic and produces code, and now we get this oversized person on the page.
Yep. And I want to point out, so the only difference here, as far as the output is concerned, is this is outputting JavaScript as opposed to Python. It's actually the same model under the hood. So the only piece of magic we're not showing you right now is that we provide a little bit of context to the model. In the case of Python, we have just one example of following an instruction in Python. In the case of JavaScript, we have like 2 examples of doing it. And from there, the model latches on and just continues and continues.
Yeah, so I feel like it was a good first step, but what I would really like is for the person to be a lot smaller and for it to be controllable with the left and right arrow keys.
Great. And we also just got a report that the emails have started rolling in, so I think that's a success for MailChimp and for Codex, so I think that's great. So let's see how big we want to make the person, maybe 100 pixels. Does that seem about right?
Let's find out.
All right, let's give that a try. And actually, what I'm going to also do is I just want to show people the full prompt that's being sent so that you can really see what's going on without any magic. So I just opened up the Chrome Inspector. We have a completions endpoint, and you can actually just scroll to the post message, and you can look at the entire bit of the prompt. And let me show you what that looks like, expanded out.
And to just explain what you're seeing here, the way this neural network works is that it's a really, really good pattern completion system that happens to work on patterns in code. It's like the world's best yes and improv actor whose domain happens to be code rather than improv.
Exactly. And so we simply provide it with this context of, oh, you're supposed to follow some instructions. And then the model realizes my job is to latch onto instructions. Okay, so let's get back to building. So we've got the person 100 pixels. Will look pretty good.
I think so.
All right, now what do you want me to happen next? What do you want to happen next?
So I want it to be at a reasonable position at the bottom of the space of the
Okay.
screen and to be controllable with arrows.
All right, well, let's do that. So first, let's set its position to, let's say, 500 pixels down and 400 pixels from the left.
Seems reasonable as far as I can tell.
All right, let's see what happens. All right, perfect. And now make it controllable with the left and right arrow keys. Now this is a pretty high level instruction. You know exactly what's supposed to happen when you push left and what's supposed to happen when you push right. You know, the model really has to infer what's going on in here, and it can't look at the screen. The model only has access to all of this text over here. And so from that alone, it has to infer what to do. Well, let's see if it worked.
Let's see, I'm curious myself. The code looks reasonable. Okay. It's quite good, but this looks like something I don't quite like. I don't want it to be able to get out of the screen like
All right,
this.
you found the problem.
Yes.
But it is alive, which I think is pretty good. But let's see if we can fix that problem. So constantly check if the person is off screen and put it back on the screen if so. So again, pretty high level. It's possible that the model won't quite know what we're asking for, but let's give it a try.
Okay,
Go
let's
ahead.
test it. Okay, this side looks pretty good to me.
It's pretty good.
What about the other side? Let's see what's happening there. Okay, so that looks good too, except that you see this flickering scroll bar at the bottom.
That is no good. Well, fortunately, you can just say disable scroll bars. By the way, I actually don't know how to do this in JavaScript.
Does the model know?
Well,
Let's
find out.
test. The model does know.
There we go. So phase one complete. The person is movable.
So there is a suggestion from Twitch to see if we can make it move upwards if you press spacebar.
All right, well, let's give it a try. So also make the person move upwards if you press spacebar. Let's give that a try. All right, you think it's gonna work?
Let's find out. Oh,
And there we go.
that is nice. We need
Yeah.
to make it also move downwards.
Oh no. Okay,
So
and
make it move downwards if you press the down arrow key.
so we now have this nice flying person.
Let's see. Okay, so now we have given it full,
Okay.
all directional control.
Good. All right, perfect. So we now have this very nice game where the person can go anywhere with very unintuitive usage of a space bar.
That's
but,
right.
You know, if you want to modify this, please feel free to try it at home. One of the great things about this playground is that it's very easy to export these commands. You know, you can almost think of this text as a new kind of source code, and people can modify it and fork it. So I think we're going to see lots and lots of games appear once people start playing with Codex.
Okay, so a moving person is quite nice, but we need to get a boulder that we'll be dodging.
All right, so let's search for an image of a boulder.
This one, definitely.
This boulder. All right, it's a very nice boulder.
I could not agree more.
I would not want to be that person having to run away from this.
Okay, so once again, we just request for the boulder to appear, and it appears. I hope it will appear.
Oh, it does appear.
An oversized
Massive,
boulder.
massive boulder.
Let's make it smaller.
All right, how many pixels?
Can you just ask it to be small?
Oh, that's a great point. Make it small.
Okay, this is too small. Can you ask it to be 4 times as large?
Let's give it a try. Huh, that's actually interesting. So it actually used a style that transformed. Now you might want to do it that way. If you want to do it a different way, you can also just say, set the width to be 4x larger. And the great thing about JavaScript, all of this JavaScript just running directly in your browser. And so we actually have all of this playground set up so that if you don't like an instruction, you can just delete it. If you want to modify it, you can always just edit it, and then you can edit the code directly.
Yeah. So I like the size of this boulder.
Perfect.
But now I want it to fall down,
Okay.
and then when it hits the ground, I want it to reappear from the top again,
Okay.
somewhere else.
Now, the thing about Codex is that, again, coding is two things. It's deeply understanding a problem, figuring out how to chunk it up into smaller pieces, and it is secondly mapping a small chunk of problem statement to code. And Codex really excels at that first part. The first part, if you ask for too much at once, it won't succeed. And so let's actually give it a try, just to say, now fall from the sky and wrap around.
Okay, I wonder if it will work. Let's find
Yeah,
out.
so this is going to require doing a lot of things. So in fact, if you notice, all that it did is it just did the first part of saying, you know what, I got to get it absolutely positioned. I put it in a particular location. It didn't do the second part. And so when Codex fails like this, the kind of thing you can do is you can just try again. And I think that, again, like one really nice thing about doing this in JavaScript is there's no punishment for getting it wrong. Right? You have a system that's very stateless that you can just re-execute and try again. Your iteration cycle can be just truly immense. And that for me has been kind of the most exciting part about working with Codex, is that it just kind of means that you get to just think about what you want, and you spend less time of like, okay, now I need to go to Stack Overflow and figure out how, whatever property it is to disable the scroll bars, which I have already forgotten. But let's now try breaking down this instruction into smaller pieces. So first, I think Codex had a good point that we should first position it to, let's set its position to the top of the screen at a random horizontal location.
Hopefully that's a simpler instruction that it could do,
Seems pretty good.
and it did it.
Yep, and if we want to verify it's actually random, we can just kind of re-execute this code multiple times. It seems pretty random to me. Now have it fall from the sky and wrap around. Let's give this
Okay.
a try. So again, still a lot going on in this instruction, so it may not work.
The
But let's
code
give
is
it a
sense.
try.
Oh, it's moving. It's going down.
Moving. Okay, we got something. We got some signs of life. Got some signs of life.
Is it going back?
And
Yes.
there we go.
All right.
Very nice.
This is very nice indeed.
It is alive. All right, great. So I think in order to put a capstone on this game, we just need to,
Indeed, there's no game if you can't lose.
sad to say, but we do need to implement that loss condition. So first, define what happens when you lose. Clear the screen and show a message saying you got squashed.
It should be an encouraging message, ideally.
Okay, well let's. So I just kicked this one off. Let's make it encouraging. So now modify that function. Now rewrite that function to also include some words of encouragement.
Excellent. I'm also curious what words of encouragement the model would choose.
So you can do it. So that's pretty good. And so the only thing is that the way that this actually was implemented is implemented as a key down listener. And what we really want is we want a function that gets called when you lose. So we can get rid of both of these, and we could try this one more time.
And so how would you make it different?
So you can say, define a function. So make a function that gets called.
Okay, let's see if it works. Oh, it is a function.
It is called you lose. And now rewrite that function to include words of encouragement. All right, let's see what happens here. And sure enough, it makes a new
Try
function.
again.
All right, let's see what happens. Now we actually have to wire this function up. So when the person and the boulder overlap at all, so constantly check. If the person and the boulder overlap at all, and if so, you lose. So I'm not even going to say explicitly call that function. Just, it's got to figure out that that's what we want. So we'll see if that happened. Ilya,
Okay.
do you want to do the honors?
Definitely.
Oh man. All right, moment of truth here. Moment of truth.
Success.
You got squashed, and a very encouraging message to try again. I think that's very good life advice from Codex right there.
Okay. I feel like it was a nice game that we built in a small number of minutes.
I think so. So we have one more thing to show you. And that with this demo, we want to help expand your mind to the possibilities that Codex can really offer.
And indeed, one of the things that we showed you in the Hello World demo is that it's very easy to teach the Codex model to use whatever API you want. API doesn't know. And conveniently, all your favorite software comes with an API.
In fact, I used to work at a company whose entire job is to build an API. APIs are out there that these days the world is really programmable, and Codex is able to hook into those APIs on your behalf. And so that the kind of end-to-end functionality that I think starts to be unlocked is that you talk to your computer, and it actually does what you ask.
All right, let's see how it works.
All right, so here we have my iPad. with just vanilla Microsoft Word installed in it. There's one little secret within it that we'll get to in a moment. But it turns out that Microsoft Word, like many pieces of software, has an API. In fact, it has a JavaScript API. And hey, we built a model that is pretty good at JavaScript.
Quite convenient.
Very convenient. So all we did is that we took this API reference and we formatted it for Codex. And so, we kind of trimmed it down. It's not the whole implementation of the whole API, but it's enough to make a very interesting proof of concept. And so let me show you the kinds of things you can do. So here is a poem that was actually one of my favorite poems as a child.
Really?
Oh yeah. It's called the Jabberwocky. It's very fun. So I'm going to paste it into Microsoft Word. And oh shoot, let me get rid of these leading spaces before we start. Sorry, I should have done this.
Greg, this will take forever.
Hold on. You know what? Fortunately, with the Codex add-in, I don't have to delete them. Delete all initial spaces.
And it worked.
It did work.
The initial spaces are gone, but all the other spaces are still there.
Still there.
And just like before, the instruction at the top was turned into code, which was then run by Microsoft Word.
Exactly. And so we're just using the standard Microsoft Word API here. So they provide a functionality for you to get your little sidebar that we show here. And we just basically reuse the exact same code that we'd written for those other demos. And so all that's going on here is that we use the built-in speech recognizer. So we didn't write that. So if it has transcription errors, we take no responsibility for it. But then we send whatever request is put here to the API, and it generates actual code in the Microsoft Word API.
And what you see here is a taste of the future. As the model gets really good, as the neural network gets really good at turning instructions to correct API calls, it will become possible to do more and more sophisticated things with your software just by telling it what to do.
And I think this is the biggest contrast with GPT-3, like the biggest step on top of GPT-3 in my mind. And this wasn't obvious to us going in, but I think it's kind of emerged from what we've built. GPT-3 is a system that you talk to, and it talks back to you. So the only impact it has is in your mind. With Codex, you talk to it, it generates code, which means it can actually manipulate, or it can actually act in the computer world on your behalf. And I think that that's a really powerful thing, that you actually have a system that can carry out commands on your behalf.
For example, let's do something a little bit more complicated.
Yep. Do you want to give it a try?
Yes. Now make every fifth line bold. Okay. Phew. I was really worried about the speech recognition part.
Yes. Well, there we go.
Oh, a success.
A success indeed. So I think that's pretty good. And I think that what this kind of demo shows you is what today's voice assistants have really been lacking. That I think that what you really need is you need a system that has the kind of GPT world understanding, so it can flexibly sort of interpolate between different languages and can really understand the intent that you're putting forth.
And while we are very happy with the neural network that we're showing you today, which is a better code model than the one we had previously, it is still only just a step. The neural networks, the code neural networks that you'll have in the future will be far better than this. So this is only the beginning of an exciting future.
And so that's the end of our demos. We're really excited that you were able to join us. And so just to review, today we showed you the latest generation of the Codex model. It's available in OpenAI's API starting today, so please sign up on the beta list. If you want to be able to play with Codex in the context of a pretty awesome new kind of programming competition, that will be Thursday, 10 a.m. We're really excited for you to get a chance to play with it. So thank you very much for tuning in. We're excited to see what you're going to build.
And thank you for joining us to experience the magic of neural networks.
I did make a presentation. It's going to maybe be up in a bit. I worked hard on it. I made it in Keynote. Everyone else made it in Google. Oh, Comic-Con keynote. There we go. That's my name, and that's today. We have a laser pointer, and we can go backwards. Oh, and we can go forwards, but can we go backwards? Oh, wow, we can go backwards and forwards. That's pretty cool. So we'll start at the beginning. This is me about 5 years ago. See a Bitcoin mug. I wish I bought more Bitcoin back then.
So just right-click on the
That's the
that might be a good idea.
UI.
But it's going to automatically do this. There's no decisions. It's just one step. All of this is automated. Right now it's creating a restore point
This is the original.
just in case you don't like how your system was before. Or maybe you're running this after a new install, but it's going to...
Had I known what
yep.
this would have ended
Agree.
up being, I probably
Here,
never would have done it.
it's going to be... And then you'll see this window.
Starting a company is
and you're going to
absolute
run
hell.
tron.bat.
But you know, when you start out with things, you don't
two
know
files,
this,
tron
right?
there.
Go into a full tilt, right?
And,
there we go, man. Comma AI on the back of an Acura ILX. License plate,
Extracted.
right? Fuel
more
on,
info,
man. It just
then run
means like
anyway.
keep the gas
Defender,
going, bro.
If you're infected, your
Or
antivirus
if you,
lines
so, you know, we put this together and you go for it. It's like, yo, let's go to the Silicon Valley VCs, man. You know, I was watching that show. It's called Comma. If we're not having a good time, there's really no point doing this. This is the original Comma team. Out of self-racing cars. You know, this was 2016, and a lot of the companies back then were way more honest and open. I think that this self-driving space is incredibly sad. I said this back in 2016. We are going to win self-driving cars. Still kind of hope so. Because, you know, I don't like losing. And why do you keep doing it, right? There's no point. You know, there's nothing you can buy with it. There's no nice life. But I like to win. I want to win, so that's why we're here, you know. I remember before this TechCrunch disrupt, I was talking to my sister, and I was like saying, like, what I really want to do is get up on stage, pull my pants up, and shit. No, really, because there's no other way. Like, how do you compete when everybody's just lying? And so I'm like, all right, we're gonna go completely over the top with it. This is all you need to solve self-driving cars. Look, it's in a neon green. It's a phone in a neon green case. Like, it's kind of a joke, but it's kind of not. You know, most of you have used that phone driving a car. Kind of a joke, kind of not. Nishta wasn't in on the kind of a joke, so I'm like, you know what? Canceled, no comma 3. Sorry, no, whoa. No comma 1. The comma 1 was canceled. Alex Roy wrote this article. He got a test drive in the car with the comma 1. The canceled comma 1 would have embarrassed the car industry. Prediction, it will be a comma 2. This was in October. 1 month later, we released OpenPilot open source. Really all the ideas started to work. We're going to be the Android of self-driving cars. Tesla's the iOS. We're going to be the Android. This is OpenPilot 1.0. You can see it has a lot less directories. I didn't think I knew how to put pictures and readmes back then. We figured it out. It's pretty nice now. OpenPilot on GitHub. And as for Alex Roy's prediction, well, the open source software included in Rio. How many of you had Neos? All right, we got a few Neo people out there. How many of you had Eons? All right, and then how many of you have comma 2s? All right, nice to see. So it took a little bit for Alex Roy's prediction to be
Lol.